Hello everyone, good evening. I hope I'm pretty much audible. Hello, good evening. Great, great guys. So today we are going to talk about the metrics. So basically we have the different metrics we have in machine learning problem statements, right? So we have been talking about regression, we have been talking about classification. So, but there are so many metrics. The important question is about how to choose them, right? So, what kind of logics we have for the metrics and how do we choose one of them? That is going to be our point of discussion. Again, a little underestimated topic, but one of the very important things which we have to discuss. So how to choose one metric. So again, a logical thought process behind that. That's pretty much what we will be discussing for today's part. Hello, Shubham. Hello, Subrat. Thank you so much for joining us, guys. So as always, it's pretty much a live session. So I'll be more than happy to take your doubts, to take your questions. So let's try to make this class more interactive. So we both will be more comfortable while talking in the class. So let's make it more interactive. And any questions, I'm more than happy to take it, and then we can discuss on that. Okay, so let's get started. So in the right metric, it is always first important to understand what metric we are talking about, right? If you remember, machine learning problem, right? So machine learning where we have the supervised method, we had more like regression type problems, and then we had the classification type problems. So both of these has individual objectives. We have seen that, right? So when I say regression, it is primarily talking about a continuous number where the output is between minus infinity to plus infinity. Any number between this range, which I'm trying to predict. So the machine learning model, which is trying to predict any number between minus infinity to plus infinity, that's pretty much what are we going to talk about in regression problems, right? And in that regression problem, we did talk about a lot of different metrics. Like we talked about MAE, we talked about MSE, we talked about RMSE, we talked about R square, we talked about adjusted R square. So all of these are one of the other metrics to evaluate how good I am in my learning process. That's what we talk about in metrics, right? So the agenda for that for today is to identify out of which we are going to choose depending on our problem statement. And similarly for classification, if you remember, we talk about like 0, 1 cases, we talk about true, false cases. So more like a class, more like a distinctive, discrete objects in the output. And for that, we prominently talked about confusion matrix. And here we had 4 terms, TP, FP, TN, FN. So these 4 terms ultimately giving 4 different outputs in terms of precision, recall, F1 score, and then we talk about accuracy. So again, in classification, that's pretty much the 4 things we were talking about in our last class. Again, the question is, we have so many numbers, even say precision is say 7 in one scenario, suppose your precision is 70% and your recall is 90%. Case 1. And case 2, you have precision as 90% and recall as 70%. So which one is the better model for me? Whether it is case 1 or case 2, which one is better for me? Whether I should go with higher precision or shall I still look for higher recall? How to identify which is the right metric for me? So all of these questions are very much important to understand. Like, okay, based on this, now we are saying that we need to have a metric, we need to have a value where this should be more than this for this particular metric. And that is the reason why we are going to find out, okay, this model C1 or C2 is better for me. So all of these questions, that's pretty much what we are going to discuss today. And that's pretty much what our agenda. So because this is slightly conceptual class, so I would really want people to interact. So like guys, whoever is part of our chat today. So try to open up and try to ask questions if you get stuck, or in general also, I'm more than happy to discuss. That's pretty much what we are expected to discuss today. But before proceeding further, just a quick introduction about myself. My name is Arpit Jain, currently working as a lead data scientist myself. And with having a number of years in analytics as an experience into multiple industries, and I really like data science and it's my passion. And I really want to share and I really love sharing my expertise with people around me, whatever I know to my best. And also with that, I am a motivational speaker, so I do talk to students regarding their career placements, jobs. So please feel free to reach out, and it's pretty much a live session anyway. So I'm more than happy to answer your even generic questions. So please open up. So moving ahead, today, as I was talking about, we will first talk about my indexes. So in indexes, we are going to have a split in two different sections. So first, we'll try to understand this problem statement from a regression standpoint of view. And second, we'll try to understand it from classification standpoint of view. So both of these problem statements, regression and classification, that's pretty much we will be covering to understand what kind of metrics should be chosen. So first, if I talk about regression, and we know that already it should be from minus infinity to plus infinity. That's pretty much what we're going to look at. And we have metrics like MAE, which is more like absolute error. Then we talk about MSE, which is squared error. Then we talk about RMSE, which is root squared error. Then we talk about R square and adjusted R square, more like relative study here. So that's pretty much the things we have from the regression standpoint of view, guys. So we will try to first understand if we have a data set which is giving us a value of absolute error, and if it's giving us a value of mean square error like a squared error, whether I should go with an absolute error identification or maybe a squared error identification would be a right metric for me. So that's pretty much where we will go in detail, and we'll try to discuss about a proper case as well, and we'll try to find out, depending on my use case, depending on my objective statement, which one is an ideal solution for me. And then accordingly, we will be choosing that particular index for me. Okay. And then accordingly, we will have a right justification that, okay, based on this reason, I'm going to choose this particular metric for me. And even similarly for classification, I will have points like, say, precision. We talk about true positive rate. We talk about recall. We are more focused towards false negatives here. Third, we talk about accuracy, overall correct predictions. Then fourth, talk about F1 score, where both precision and recall is needed. So again, guys, we have to first logically understand whether precision would be more ideal to my scenario or whether recall would be more ideal to my scenario. I can still look for both precision and recall, and I will be showing you one of the good examples where we might still look at the both F1 score, and even where we're going to find out accuracy is one of the right metrics. So all of these plays one of the other important aspect in depending on my industrial problem statement which I'm trying to solve, but we have to understand where and how does it important for my problem statement which I'm going to look at, right? So that is where we will have a detailed study on top of that, and we'll try to find out how to look at each of these different metrics. So that's pretty much what we're going to talk about. So moving ahead. So just to give you a quick recap again, so artificial intelligence, as we were discussing, sorry guys, I think I got dropped for a second. Okay, so what I was talking about in terms of artificial intelligence and machine learning. So artificial intelligence, as I was talking about, is nothing but set of algorithms where we are trying to mimic my human intelligence. I've already talked about this. So never forget, artificial intelligence is not an alien terminology. I've been seeing people getting really confused with the terminology such as artificial intelligence and then robotics and then machine learning. So there's so many things floating around as your keywords. We tend to get confused by all of these terminologies. Again, just to tell you how the bifurcation happens. So we have artificial intelligence as my bigger umbrella here. It is of two types. First is artificial general intelligence. We also talk this as strong AI. Second is weak AI, where we prominently talk about machine learning. So AGI, we talk about strong AI, multiple problem statements, multiple problems we are trying to solve at the same time. Example would be robotics. So robotics, this robot can probably run, can jump, can probably even talk and do your work. So robotics, I'm trying to do multiple things at the same time. Artificial general intelligence is pretty much a research field. So we can still take this as a research field. Still the researches are going on here. But in the weak AI section, we talk about solving one problem at a time. So we're going to look at, suppose I'm going to find out person who's going to default in my loan prediction case, payment of my loan, or finding out a spam email. So all of these is one single problem statement. I'm not doing anything else apart. That is where machine learning comes into picture. And interestingly, this machine learning has another advanced part where we talk about some specific problem statements to be solved. One of those advanced techniques where deep learning comes into picture. So deep learning is pretty much a part of my machine learning here. So that's how we take care of things, okay? That's how the division of things happen. So we always start with taking artificial intelligence as basically my core area where we're going to figure out the things. So it is nothing but set of algorithms at the end of the day, which is trying to mimic my human intelligence. And ML, machine learning, is type of artificial intelligence where deep, again, one of the ML algorithms we have. So deep learning is a sub part of ML, and ML is one of the sub part of artificial intelligence. That's how we define things. Just one quick recap again. So in ML, we're going to talk about artificial intelligence. That's where we have the sets. And the whole intent behind doing the machine learning is to learn the data which we have, give some meaningful business outcomes by doing some pattern recognition. So whatever data we have, we are trying to first understand the logical relationship between each of the pointers. And from that logical relationship, we are trying to generalize it, which can be further used for future predictions. So I'm trying to train my model, I'm trying to train my machine saying that, okay, if suppose A, B and C has certain X, Y and Z values, this will eventually result in say T1 as my target. So if A's value is X, B value is Y and C value is Z, this combination effect is ultimately resulting in T1, which is say some value here, whatever the value we want here, right? So that's pretty much how we are trying to generalize it. And likewise, for all those multiple options, T1, T2, T3, for all the multiple different values we have, find the dense pattern relationship between my ABC with my target. That's where the pattern recognition comes. The objective of pattern recognition is to find out the relationship between these ABC and the T1. So this ABC is also called as independent features, independent variables in that per se. And T1 target which I have, the output is also called as dependent variables because it is actually dependent on these A, B and C. If my values of A, B and C changes, likewise my T1 changes. So it is directly dependent on A, B and C with some factor. And that is what the objective of any methodology is, to find out that factor which is through which this T1 is varying if I'm kind of changing the values of A, B and C. So that is where the core objective of pattern recognition comes. And the patterns should be trained to show the output in a desirable manner. So output, whatever my output is, as I've said, whether it is a regression, whether it is a classification, whatnot, I'm going to find out output depending what I'm going to look at, what I'm expecting from the output, what I'm going to look at, what I'm expecting as a result. Accordingly, the pattern training will be happening. So quickly moving ahead, guys, we're going to spend some time on this slide where I have just kind of generalized the different pointers here. So look at these different problem statements. So if you remember, we talked about two methodology. In ML, we have two methods, supervised, and we talked about unsupervised. Right? So I have this divided into two sections. So above section is for supervised mechanism, where we will be going in detail for these two. And then one supervised here, and how we're going to evaluate this, again going to get a clear part here. So for regression problems where the target is more like a continuous number, and that is where we're going to look at square error, absolute error, R square, adjusted R square. So there's so many different methodology involved, there's so many different metrics. How to choose the right one for me, that is pretty much we're going to go in detail. And similarly for classification, you can see precision recall, pretty much accuracy, F1 score. We have ROC, AUC, area under the curve. Then we talk about accuracy as a separate metrics. We talk about the log loss function. So pretty much, again, there are a couple of more things which can be still tracked in terms of evaluating your model. So again, here in classification, about these, which one should be chosen where, and I'll show you a practical example also how you're going to figure out the things. Likewise, in unsupervised, we have two other methods. And in others, we still have something called as cross-validation error, and then some method to find the K in, there is some other detailed methodology. So we're going to talk about these in our separate discussions where we're going to take up the concepts likewise. So today we are going to be primarily focused on regression and classification both. And we'll try to find out which metric should be ideally given to each of my problem statements here. So moving ahead, just to give you a clear understanding of the different indexes we have. So primarily one of the most frequently used metric which we have in regression problem is RMSE. nothing but, we also call this as root mean squared error. And if you read it out, it represents the sample standard deviation of the differences between the predicted values and the observed values, also called as residuals, also called as errors. So what it is? Let's try to first quickly understand. So as I've told you, error is nothing but predicted value and observed value का difference. So we're going to find out if my true value is, say, suppose 100, and I have predicted this as 95. So what is my error here? My total absolute, the observed value minus the predicted value. So it will be nothing but 100 minus 95, which is 5. So error or the residual in this case is 5. And what if my true value is 100 and I predicted 105? So what is an error in this case? Again, we're going to talk about 100 minus 105, which is going to give me minus 5 in this case. So basically, if you understood, error can range from minus infinity to plus infinity. This is the range of my error, right? So I'm talking about error going from minus infinity to plus infinity, where the difference between the observed and the predicted will be calculated in form of residual or error, we call this as. To negate this effect of minus sign here, we take the square of this error. So what we do is, this 5 gets converted to 25, and this minus 5 also gets converted to 25 again. So what we did, we just negated the effect of the minus sign, and we ultimately took the squared error of it. Fine. So we have two errors now basically. First, for the first case, it was 25, and the second also we have 25. Now what we do is we take the mean of it, which is nothing but 25 plus 25 by 2, which is again 25 only. So mean is 25, and now for this mean we are going to take the root of it. So root of 25 would be my step 4, which is going to give me the 5 here as a result. So RMSE for this situation is 5. Similarly, let's try to decode this from the formula as well. It is pretty much talking the same thing. Let's try. I'm trying to remove the ink from here. Let's try to look at this. So what did I say? Step 1, difference, which is nothing but error. Second, square of difference. Third, we're going to take mean of square difference. Fourth, take root mean of square difference. And now let's try to find out. So when you want to sum, when you take a difference first, so this is nothing but observed minus predicted. So this is my actual minus y hat predicted, and I'm making it as a square, and I'm taking a sum, so which is nothing but from one value, starting from the first value till the nth value, and this whole summation is divided by n, and then at the end we're going to talk about root mean of this. So RMSE is nothing but root mean square error, where I'm going to talk about error, mean, square, and then root mean of that. Similarly, if we talk about MAE, which is more absolute in nature, we're going to talk about the absolute difference. Again, for the same two scenarios, where originally I have 100, and then we talk about 95, so which is going to give me 5 as an error. And second case, 100 predicted 105 is going to give me -5 and an error. So what we do in MA is we take mean absolute error. So this 5 absolute of 5 will give me still 5. And when I take absolute of -5, it is going to give me +5. So ultimately, even I negated the effect of minus value here by simply doing an absolute. 5 and 5, my negative value is gone, basically. And when I take a mean of 5 and 5 here, again would be what? 5 plus 5 by 2, which is again 5. So MAE again also in this case is 5. So let's read it out. So MAE is the average of the absolute difference between the predicted and the observed value. And MAE is a linear score, which means that all the individual differences are weighted equally in the average. It is taking the actual difference between my true values. Right? So from the formula perspective, we have the still actual minus predicted, and instead of taking the square in the previous example, we just took an absolute of it, summed it up from 1 to n, and took the mean of it by n. Right? Now the question arises, the burning question arises, because both of these situations, RMSE and also MAE, they both are giving me the same result, which is 5. Shall I take RMSE or shall I go with MAE in this situation? How do I know that, okay, RMSE is better or MAE is better for my problem statement? So the next question follows, which one is actually better for me? So the problem statement which we have discussed, where both the values of MAE and the RMSE are coming as same, let's try to do some minor tweakings in our data set, and let's try to see how the values changes and how the different results are affecting my calculations part. So obviously it is very easy to understand and interpret MAE because it is nothing but the direct differences of my true values. It directly takes the average of my offsets, which is my error. Simple. I don't have any complex calculation there. So it becomes a little easier to interpret MAE, where RMSE penalizes the higher differences more. How does it do that? This is a very important statement, guys. So RMSE is going to penalize the higher differences. So if my predictions are way off, that means if I have higher differences, if my error is high, I'm going to have more RMSE value. Obviously, higher the RMSE value, lower my model performances. I need to have lesser error. And let's try to validate this statement. So I've taken two cases. Look at the actual values, 2, 4, 6, and 8. Both the cases, 2, 4, 6, and 8. But for the case 1 or my model 1, I have the predicted values here. So 2 got predicted as 4, 4 got predicted as 6, 6 got predicted as 8, and 8 got predicted as 10. So what are my differences? So 4 minus 2, 2, 6 minus 4, 2, 8 minus 6, 2, 10 minus 8, 2. These are my differences, right? And likewise for the case 2, 2, 4, 6, and 8, same problem statement, same data set. But now in this case, prediction is little different. So I have 2 got predicted to 4, 4 to 6, 6 to 8, but 8 got predicted to 12. So what is my updated difference? Error 2, 2, 2, and 4. Correct? So what is the MAE and the RMSE calculation for this, let's do that. So MAE would be for first case 1 if I have to find out. So MAE, case 1 MAE would be what? 2 plus 2 plus 2 plus 2, which is 8, divided by number of observation for the mean is going to be 4, going to give me 8 divided by 4, 2. Correct? So basically what we did, 2 plus 2 plus 2 plus 2, which is 8, sum is 8, sum, and here sum is 10, right? So MAE would be 8 divided by 4, or I'll just in fact do the calculation here. MAE is nothing but 8 divided by 4, which is 2, and RMSE would be what? Squaring of these errors. So 2 became 4, 2 became 4, 2 became 4, 2 became 4. So 4 plus 4 plus 4 plus 4, that becomes 16. So 16 divided by 4 under root. So 4, 4, 4. Again, this became 2. So both my MAE and the RMSE for case 1 is 2. And that is what we have written here. So it is 2 and 2. But let's try to find out for case 2. So for case 2, the sum is 10. So MAE becomes 10 by 4, which is 2.5, and RMSE became, squaring is 4, 4, 4, 16. So the sum is 16 plus 4 plus 4 plus 4, which is 28. So 28 divided by 4 ka under root, which is going to give me 2.65. Now can you see the difference? The moment I have the values which is way off, this 12, I had the higher error, which is 4 compared to 2. In my second case, my error is 4 now. So practically by doing this, I am increasing more error, and with this error, my RMSE got affected a bit more. For all the true cases, it was even, but the moment this error got increased, my MAE was still 2.5, but my RMSE got increased bit more heavily. And that is where we can see that RMSE penalizes the last value predictions more heavily than MAE. Clearly present here. So a situation where I'm seeing that I have the prediction results which is way off than my actual results, then maybe RMSE would not be the ideal solution for me, because it is very subjective to my outliers here. So in general terms, if I have to say, as we could see, it is going to penalize my last prediction. So in the squared error over a set of results, it is finding basically its mean and minimizing the absolute error. The MAE part, it is basically finding its median. I'm going to talk about its absolute error. So mean square error is more related towards mean, and mean absolute error is more related towards median. So absolutely, if my data distribution is showing more skewed values, or I have very much potential outliers in my data set, then maybe RMSE is not a right metric for you. I would have to go with MAE, because MAE is more robust to my outliers where RMSE is not. And we have proved this also. So it is very much subjective to the different errors we have, right? So situations where I'm able to see more way off results, more skewed results, I would rather should go with MAE and not MSE. Clear? So technically both MAE and RMSE, they both ranges from 0 to infinity. That's pretty much what my error value would be, and the unit for both are same. While another metric, which is R and R squared, so out of MAE and absolute errors and the squared errors, we understood which one should be chosen. But now, how can we compare this MAE RMSE with my R and the adjusted R square? So this R and the adjusted R square methodologies, they are slightly different and they are more relative in nature. Now here we are not going to talk about the error from 0 to infinity. No. Rather, we are going to stick to a smaller range, probably 0 to 1, and then we're going to find out how the variability of my data set is getting explained. So this R square and adjusted R square are often used as a well explanatory things, and where we're going to find out and explain how well my selected independent variables explain the variability in my dependent variable. So if my R square index is suppose 70% or 0.7, that means that my current model, whatever I have, and the current feature sets which we have taken, this set of feature set is able to explain the 70% of variance on my target variable. So for that 30%, remaining 30%, I might need to add a few more data sets. I might need to have few more details so that the entire variability is explained likewise. So that's pretty much what R square means for you. And again, we have also understood adjusted R square. This is highly subjective to the number of features we are going to consider. So we discussed about the formula also, where adjusted R square is highly dependent on the number of features we are going to pass in my calculation process. So it is subjective to the ratio of the number of rows with the number of features we are going to take. So we have the detailed formula there. So higher the number of features, where the number of rows is still the same, I'm going to penalize my calculation process, and my R square gets adjusted with the penalized value. So adjusted R square makes more relative sense in terms of giving the true relationship between my available independent features and the target variable. Cool. So this is all about my regression index, guys. Next, very important, now we're going to talk about is my classification index. So we have understood, depending on my objective statement, depending on the error we're going to look at, depending on the different type of distribution of data, how we are going to choose a different metric for me. But respectively, for a classification problem, we have to find out again how to choose the different factors which is ultimately going to decide for my classification process. So how to choose different metrics. So we talked about precision, we talked about recall, we talked about accuracy, we talked about F1 score. So out of all this, how to identify which one is better for me? A classic example, so primarily this classification choices, they are based on two deciding factors. It is based on two deciding factors. Number one is the number of instances per class. Very, very, very important. Here we talk about a very classical problem of class imbalance. I'm going to show you a real example also with this, how this plays an important role. Number of instances per class. I'll quickly show it to you also. And the second is the business use case to solve. I'm trying to look at the objective statement of my problem. So what exactly I'm going to look at, whether I'm going to solve a problem statement where I'm going to look forward to higher true positives, or my objective is to have lesser false negatives, or I'm still trying to balance both of them. or probably I'm going to look at equal distribution for both of the classes. So it is highly subjective to the problem statement, the objective of the problem statement which we are trying to solve as well. So let's take a practical example, guys. Okay, let's take a practical example. Suppose that you have a data set which is having, say, originally, I don't like O, so let's remove this. So I'll put it as, like, say, actual A. I have two classes, 0 and 1. 0 is having 90 values and 1 is having 10 values. So total I have 100 data points. Okay, imagine like this. So I have actual values 100, and out of 100, 0 is 90 and 1 is 10. Another, I'm saying I have predicted case. Again, obviously, since I have 100 here, I will also be predicting the same 100. And for this predicted 100, my zeros got generated as 70 and ones got generated as 30. So what did I say? My zeros are 90 and ones are 10 in the actual cases, but in the predicted cases, 0 got converted to 70 and 1 got converted to 30. And my objective statement here is, I'm trying to find out, say, probably precision, recall, accuracy, and say F1 score for class 1. Correct? I'm more focused towards how my precision, recall, accuracy, and F1 score for class 1. Or let's try to reverse this up. Let's try to reverse it so that it will be more higher data points to solve. So let's make this as class 1 as 0 and this as class 1 and class 0. Okay, fine. So first object, when I have this precision, recall, accuracy, and F1 score, as I've said, we need to have the values which is true positive, false positive, true negative, false negative. If I have these 4 values, I can pretty much easily calculate all of them. Correct? Let's try to build up a confusion matrix. So I have this confusion matrix with me. I have the actual values here and I have the predicted values here. So I have the two classes 0, 1 and I have 0, 1. Okay. So let's try to understand this. Actually, I have 0 as 10 and how many I have predicted? 30. Correct? So originally it was 10 and predicted is 30. So there is something wrong here. I have over predicted it. Correct? I need to find out this value. And also for the one case, originally I have 90 and I have predicted 70. So what are these 70? Whether these 70 is still the class 1 or I still have few values of 0 in it. Let's take an assumption here, assuming all of this 70 is correct. That means all 70 are ones here. If all 70 are ones, that means the remaining ones, which is 20 left out here, got predicted in this part. So out of this 30, now 10 is 0 and 20 is 1. With this logic. Correct? Let's try to solve it for the same issue here. So now originally I have 0 and I have predicted how much? 30 here. So let's try to find out first. So assuming that my 1 is my true positive case. So out of all 70, I have predicted the 70 as correct. Correct? So my actual is also 1 and my predicted is also 1, which is 70, or my true positive in this case. Correct? So actual also 1 and predicted also 1, which is 70. I predicted 70 as correct. So if I have predicted all 70 correct and I also predicted total as 70 only, so what is my false positive? Which is 0. So I predicted out of 70 everything is correct, so everything is falling under 1. So if my 70 is correct, my by default false positives become 0. My predicted case is 1 and out of them actual is 0, so it is wrong. So it's basically 0 here because all of the predicted ones are correct. Now let's try to find out predicted zeros. I have predicted 0 as 30, and out of these 30, how many are zeros and how many are ones? So out of this, the correct is 10, and how many are ones? 20. Correct? So out of this 30, my 10 is 0 and my 20 is 1. That's what we have figured out here. So this is my true negative and this is my false negative. So I have the values here. My TP became 70, my FP became 0, my TN became 10 and my FN became 20. So quickly, with these numbers, I'm just going to erase few ink from the right hand side here. So now let's try to evaluate the different metrics here. So we have figured out my confusion matrix. So with this, what is my precision value? Precision is nothing but, precision is nothing but TP by TP plus FP, which is nothing but 70 by 70 plus 0 or 1. So precision is 100%. Agree? That is pretty much what precision means here. And likewise, if we try to call recall is what? TP by TP plus FN, which is nothing but 70 by 70 plus FN is 20. So it is 7 by 9. And we talk about accuracy here. Accuracy is nothing but TP plus TN divided by TP plus TN plus FP plus FN, all the values. So TP plus TN, that will be 70 plus 10 divided by all of these numbers. So 70 plus 10 plus 20 plus 0, that will become 80 by 100 or 80%. Right? So precision is 100%, my recall is 7 by 9 and my accuracy is 80%. And can you see all of these metrics is highly subjective to my data points here? And that is where we say it is very important to understand how my distribution of my different classes is. So now with this part, even though I'm getting precision as 100%, but my recall is still 7 by 9. Somewhere around close to say 75 or 76% roughly, and accuracy is 80%, right? So we are trying to understand how each of the classes are getting identified, how the values are changing for each of them. That is something which we have to understand practically, right? So that is one thing which we have to look at. Second, I talked about the business objective. Again, that is very important. Suppose we were talking about this another day, that I'm talking about loan defaults, right? So I'm only looking for the people who have actually defaulted. So I have predicted them as default and they're actually defaulter as well. So I'm more focused towards the true positive scenarios. So where I have predicted them as 1 and also they were actually as 1. Situations like this, I'm more focused on true positive rates. So might be precision is my good metric here. And situations like this, we talked about healthcare industry, where we had, I predicted the person is having cancer and he did not have the cancer. I might start chemotherapy for him, which is not required. And the vice versa of it, I said that he is having cancer. I said that he's not having cancer, but he actually had cancer. I missed his medication. So in this scenario, both of the situations become important. I cannot miss the medication part, and also I cannot just start randomly giving chemo to everybody here, right? So maybe both precision and recall are important, and when both precision and recall are important, I would rather go with F1 score, the harmonic mean between precision and recall. So likewise, it is very subjective to the problem statement, what are we looking at, but ultimately we're going to look at these 4 individual key terms: true positive, false positive, true negative, and false negative. And based on this, we are going to calculate the different metrics depending on the objective statement. Then we'll further choose which one is more ideal for my business scenario. Make sense, guys? So this is pretty much what I intended to cover today. Any questions, more than welcome. But thank you so much for being patient and listening to me. So this is pretty much what we wanted to cover today. And I hope you got a fair sense of how to choose different metric here, whether it is a regression problem or whether it is a classification problem. Accordingly, we have to identify which one is the right metric for me. And that needs a set of process in the background. And that is pretty much what we discussed today as well. And listening to, right? So cool with this, guys. I think we are good to wrap up. Again, try to solve as many questions, and when you see more problem statements, more clearer to you with time. So that's always the case, right? But thank you so much again for being patient and listening to me. So with this, guys, we're gonna wrap up. See you in the next video, where we're gonna again come up with something really exciting the next day. Till then, thank you so much. Keep studying. See you in the next class. Thank you so much.